Hello and welcome to Gensim in Python, explained for beginners. I'm your instructor Kashif Murtaza from AI Sciences, and in this particular video we are going to talk about a very popular natural language processing package called Gensim. And we will mainly see why Gensim is so popular, and we will also see the Gensim code in a nutshell. And finally, we will build a very cool application very quickly in Python using Gensim. About our channel, AI Sciences, if, for example, you are new to AI Sciences, at AI Sciences, we actually deliver a lot of data science and artificial intelligence services. We provide a lot of services. The services include online courses, books, and in-demand customized software development and whatnot. So all these things are related to basically data science and artificial intelligence. So for example, in the description below, you can see the links and you can just navigate through. And if you, for example, are a regular viewer of our channel, then welcome to another very fascinating video on the platform of AI Sciences. So let's start. First of all, why Gensim? Well, there are a lot of other very famous natural language processing packages, libraries. For example, a very famous library called NLTK, Natural Language Processing Toolkit. Another one, which is very modern, is also known as Spacey, very famous. They're very cool. They have their merits, but Gensim has some very unique features. And for example, it's super fast. I mean, it is written in a way, its code is highly optimized and parallelized, and most of the routines are C routines. And it is extremely fast. Further, data streaming, you do not need the whole data, the training data to build any model. You do not need the whole data in the RAM. I mean, it just streams the data whenever it requires the data. It picks it and load it into the RAM, and after that it just throw it away. And that makes it super cool for very, very large data sets, because you do not need all the data every time to fit in the RAM. And large corpora, very large data sets, they can be streamed, they can be parallelly streamed, and it works really cool and really very well on large data sets without any problem. No platform dependence. I mean, you work on Linux, Windows, OS X, or wherever. I mean, you're just good to go. The code is open source. It's completely open source, available. It's proven by thousands of companies. They're already using Gensim. Over 2,600 academic citations, 1 million downloads per week. It's really, really famous. And above all, there are pre-trained models and corpora that is available along with the Gensim. Do look here at the link here that I'm actually highlighting right now. So Gensim is if I just want to say the discrimination of Gensim over others, or superiority of Gensim over other packages, then and let's say somebody asked me to say it in one word, I will say it's really, really fast. It's efficient, very, very efficient. This is, for example, Gensim in a nutshell. You have a lot of modules in corpora, models, similarities, downloader. You can just directly stream the data from S3 bucket. How cool. You can build your model. That's a latent semantic indexing or latent semantic analysis, also SVD-based model. There are a lot of other models as well, similarities. And then you have a query to just get the most similar document with you. That's mainly, topic modeling library, and there are a lot of other very cool features as well. let's build a very cool application in Python using Gensim. Obviously, very basic one, but let's explore some of the functionality, some of the basic functionality of Gensim in Python. So go. So here, by the way, if you want to install Gensim, just write pip install Gensim and you're good to go. If you want to install using pip, there are conda variants and other things as well. So from Gensim, we are going to import corpora, models, and similarities for now. We're not going to use download because we are going to use 20 news group data from scikit-learn as our corpus. So let's import that as get data. We will be using topic classification. We will be building actually topic classification, topic identification app using classification modeling. So for evaluation, let's have a train test split. That's for frequency counter. Regular expression is needed for very basic tokenization of text, and NumPy is almost always somewhere is required in data science coding. So let's load all the packages. Yeah, it's there. Okay, let's now get the data, the 20 news group data, and let's remove the headers, footers, and quotes. So that's our data. X is actual list of lists where each list is a document. So X is list of documents. Y is the target, which is the topic. And these topics are in Y, these topics are in integer numbers. And the target names, these are actually the corresponding strings. Not corresponding, I mean the strings indexed by those numbers. Let's see, for example, some, no. Let's see, for example, some data, for example, x0. Let's print it. Let's print x0, and we get this document. I was wondering if anyone out there, I mean this whole document, that's one document. There are a lot of documents. Let's see how many documents are there. For example, let's print the length of x. And actually there are 11,000, more than 11,000 documents, obviously of different lengths. I mean, different documents may be of different lengths. And we can have topics as well. For example, if we go Y and we set OK target names. So whatever Y0 is, if we set the Y names and we see what is this thing, so that will be the topic. So the topic here is autos, REC autos, total these many, and that's a document. We can have, we have several documents. So you can see each document at the end of the day is a string. So basically it's a list of strings. X0 is, if I just print the type of X0, for example, let's say, if I just print type of X0, we can get what is inside this. So this is basically a string, so list of strings. Fine. So let's split the data and just hold 10% of the data as test and rest of the data being training. And so far we have not used Gensim at all. Let's use some very basic stop words, the words that are mostly occur in any document and are not very discriminative. Let's just remove them from the all the documents, and also split the documents and tokenize them. Just get the meaningful words. Here I'm using very basic tokenizer that just, pick every alphanumeric consecutive words. Maybe you split based on spaces and punctuations and whatnot. But better tokenizers do exist. So let's do that. It may take some time. And after that, once we have this text, for example, if I just show you now, texts, for example, 0, if I just print that, you will see a list of words or tokens. So these are so many tokens in the 0th document, to say. Yeah. So there are a lot of documents. Again, the total number of documents are the same, but these are just the tokenized documents. So if I just print the length of texts, I get the same thing. Oh, no, why not? Oh, okay, because the 10% of those, they actually go to the test data, and I'm just using the training data right now. So far, I have not used Gensim. Okay, fine. Now, let's see in our corpus, which means large body of text, and in our case, we have total more than 10,000 documents. Let's pick all the words and see how many times each word or token appears. And then the words that are really less frequent, let's say they appear less than 10 times, or at least, I mean, at most 10 times, let's just remove them from the dictionary, and the rest, let's keep the rest of the words, and let's call this as processed corpus. Okay, that's it, done. Now Gensim will begin now. From processed corpus, we are going to build a dictionary. Dictionary is basically unique, all the unique tokens. So if you see in this particular case, we have 12,401 unique tokens. And if we just print different tokens, so this single quotes have index 0, this 38 has index 1. So these are indices. So dictionary is just the indexed representation. So for example, this token Murphy has index 1, 3, 4, 5 in our dictionary. And the total, obviously the total number of words in our dictionary, your token in our dictionary are 12401. So the corpora has a dictionary, and we can have processed or unprocessed corpus, whatever, and it will build a dictionary. That will be required in further processing. Next, what we do, we convert our text, our processed text to document to BOW. BOW is just the bag of words representation. So think about this word or token addition. It has index 1402. And if in each document, if this addition appears, for example, 7 times, then at the index 1402, we will write a 7. So basically it just counts how many times each word appears, and it just places the counts of every word on its indexed. These indexes are guided by the dictionary. So that is the bag of word kind of counts. These are just counts. One bad thing about bag of words is it doesn't care about the sequence of tokens, in which sequence they are appearing. It just counts wherever they appear. So we can use the dictionary again to convert our processed text to the bag of corpus. Let's just think each document now becomes a bag of word representation. It's a sparse representation. For example, index 0 appears 2 times. The word at index 0 appears 2 times. The word at index 4 appears 3 times. So the first value is the index of the token, and the second value is its count. This is sparse representation. All the tokens that doesn't appear or the count is 0, they actually are not listed here. So that's a sparse representation. So once we have converted all our corpus to its bag of word representation, now we are ready to actually build any beautiful models that are available in Gensim. There are a lot of models. Most famous models are particularly for topic modeling. TF-IDF model, or latent semantic indexing, or this Richlet analysis model. There are other models too. So let's try this model, which actually will build very useful features, feature vectors, or you can call it them. Each document will be represented as a sequence of or a vector. Vector of numbers. It will be represented numerically rather than in the form of string, which has its own merits, a lot of merits. Yeah. So let's use this TF-IDF model. In particular, this TF-IDF model is also known as term frequency, inverted document frequency. This actually, what it does is, rather than writing here, for example, the word 4, the word at index 4 appear 3 times. So in the whole corpus, if some word is appearing a lot many times, then its weight actually decreases. So rather than have a count, we have a weighted count. And the words that are very rare they have large weight. And the reason for that is the words that are very rare are expected to be the words that discriminate different documents together, and they must have so the words that are appearing in many documents, a lot of documents, those may not be very discriminative words, but the words that are appearing rarely in rare documents may be very may represent the document in with respect to some topic, or may represent the whole document, or some very useful facts of the document. So this TF-IDF actually is kind of the same thing, but these counts, they're actually weighted counts, and the word that is more frequent in the whole corpus get the lower weight. That's it. And this LSI model is actually the singular value decomposition based model, and this LDA model is more actually very similar to principal component analysis and the related kind of family of models. So let's build that model just like so, and then let's build a similarity matrix which actually has the index similarity. It's really fast. I mean, it may take a couple of more seconds, but it will return very quickly. So once we have this index with us, now we can have any other document or the same document, and we can find out the best match document. So what we are going to do is we have our test set. We are randomly generating some document from the test set, and that's our query document. And then we are obviously converting our query document to, again, the bag of word representation. And then we are actually finding out its similarity to all the available documents. So whatever documents it is most similar with, the topic of that document is assigned to this document. And that's how we will classify whether our predicted topic is the same as the actual topic or not. So let's do that. Here, the predicted topic is this, and the actual topic is this. That's for randomly generated document. And by the way, this document doesn't play any role in the training part. Let's do it again. So we predict space, and the actual was also space. And let's do one more times. Oh, great. I mean, yeah. So luckily 3 times we have predicted exactly what should be predicted, but the errors can also be there. Oh yeah, that's one error. I mean, errors can also be there. But you can see, I mean, you have built on a real corpus, 20 news group. That's not a small corpus. Although in the literature of corpora, I mean, that's not a big corpus either, but you have built that very quickly. I mean, yeah, I mean, just a few lines of codes and all explanatory and very quickly. And you have just built a topic identification module. Gensim is, I mean, much more powerful than this. It is not just about computing just the similarities of the documents. There are word embeddings, very fast word embeddings that are available there. And you can build analogies of different words together. Very cool applications can be built from using Gensim. I've just given you here a very small or very brief snapshot, a kind of snapshot of Gensim, but do look at the documentation of Gensim and explore it more. It's really fast. I mean, it's okay to even to use CPU for large data. It actually is really fast. Yeah. So that's about Gensim, very brief and very kind of abstract kind of thoughts on Gensim. I guess you have liked this video. If so, please press the like button, subscribe our channel, and share this video. That's a cool video. Share this video with your friends. I mean, visit our site. I mean, we have a lot of other things, very cool things, related things to data science and artificial intelligence that you might need, that is available there. So, yeah, with that, thank you. Hope to see you next time.